In this lesson, I want to go over these pairs plots. These are big, uh, crazy things with lots going on and lots of interesting information in them. And so I just want to quickly go over what I see in them, with the caveat that I'm not going to catch everything, and I can't explain everything. Some things are just, oh, maybe I should look into that a little bit, and I don't know why. It's not. This is where it's a little bit of an art, not a science. And this is the sort of thing that isn't shown in a lot of, like, you won't see this in a paper. This doesn't make it to publication. This is for you to look at and kind of try and figure out what you see in it and what you want to do with that information. So in this regression, body mass is going to be my y variable, my predictor. Unfortunately, with the way it was put into this, it shows up on the y-axis, so you're going to have to tilt your head to see some of the relationships. So this is flipper on the x flipper on the x-axis, flipper on the y-axis. So these are flipper lengths, and on the x-axis here is body mass. So in this one, we see a strong linear trend. So this is probably something that we're going to want to fit in the model. Again, I wanted to show this one first because we have this strong trend, and it's clear what's going on. This trend won't be exactly what we see in the model though, because again, we have it flipped. It's like this. I actually want it like that. I want this is body mass, this is flipper. I want flipper. So we have to follow it. I'm gonna stop doing that now. But yeah, so we see a strong upward linear trend. And so that's something important for the model. We also see maybe this one is also a pretty strong linear trend. We've got a flipper and Coleman-Len are relatively correlated. This plot here shows the correlation between these two. So the R-squared value would be that squared, which is relatively large for something like this. The correlation is 0.653, which is a decently large correlation between predictor variables. So checking the variance inflation factors might be an important thing to do here. If we actually look at all of these values quickly first, we see just a lot of correlation. All of these correlations are significant, except for maybe this one, which corresponds to that. So this is, if I correlate delta 15 and Kalman length, and Kalman length, that's similar to, well, that's Kalman length and delta 15, so that's why delta 15 Kalman length, delta 15. Just trying to get you oriented with how to actually read the x and y axes of these plots. So with the exception of that, all of these are significantly correlated, or so it would seem. Some other things I see, I'm just looking at this area for right now. Some other things I see, it looks like there are two different trend lines, and if I treat them as two separate groups, I'll get positive slopes. However, the correlation, I don't know why I started my circle there, the correlation is negative. We actually have a significant correlation in that direction. Um, so there's some sort of hidden groups going on here, and that's not good. We don't want hidden groups in our data. There's something else going on with this data, and ultimately, it's relatively obvious what that should be. We have three different species. They're going to have different characteristics, and they're going to be grouped differently. Different species are different sizes and grow in different ways and have different body shapes. So we want to account for this in our modeling and even in our visualizations. So I'm actually just going to scroll down to the second plot I made, which is all of them. And so now we see, for example, in that last one we just looked at, which had a negative correlation, again, the correlation was like that because it wasn't treating them as two separate groups. Instead, we have three positive correlations. And so this is body mass versus Kalman depth. Again, it's body mass versus Kalman depth. We'll have to flip it when we actually do the modeling. But we expect there to be, at the very least, different intercepts for Kalman depth depending on the species, which means we would just include species as a predictor and Kalman depth as a predictor, and that should be fine. That strong positive association between body mass and flipper length we actually see is, it looks like It could be three separate lines. They could be the same line. There might be, it's hard to really tell. I'm going to see if I can zoom in and then zoom out again in a good way. I cannot. Maybe I can. Yes. It looks like there might be a steep slope here, less steep, and somewhere in between here. It looks like they might have different slopes and intercepts, or it looks like I could force a line to have the same slope in each group, and maybe that would simplify the model in a significant way. It's hard to really tell. So this is where modeling comes in. Um, so that's a hypothesis that we have now generated. Um, Looking again just at body mass because it is our predictor variable, let's look at delta 15. So delta 15 and body mass. Again, it's this flippy dippy thing. If we had included, if we don't separate based on species, we might get a strong negative slope, and that would be delta, we're looking at delta 15, so body mass and delta 15. We've got a negative correlation, negative 0.54, which is relatively strong. Chinstrap and Gen 2 both have negative, and Adderley has positive correlation. So we're actually seeing Chinstrap and Gen 2 are maybe slight negative, with this one slight positive. So this is maybe something to investigate in the model. And delta 13, I'm actually going to zoom in on delta 13 just because there is something weird going on here. It looks like we've got 3 different levels of delta 13, and that's something we might want to look into. I believe, having looked into this separately, I don't think it's included in this file, but having looked into this separately, delta 13 is heavily dependent on the island. And so there's something special about island that I didn't mention in the text, but I'm going to quickly go over now. So the island is here, and if I look at body mass based on island, I immediately see something. So there's purple here, purple here, purple here, and it doesn't look like the body mass for purple, which is chinstrap penguins, is different for different islands. For orange, well, orange only exists on one island, green only exists on one island. This probably isn't going to be a good predictor. Um, it's something we don't want to include, but if we include delta 13, we probably want to also include some information about the island, which is where things start to become an issue. Or, oh, no, I have that wrong. These three, this pattern here probably doesn't depend on island because orange is only on one island. So there's must be some other explanation for that. I'm not actually sure what it might be. Uh, that's your homework, investigate that. Looking at other categorical predictors, so something like clutch, if I look, I can see this pattern of green and purple the same, orange higher, green and purple the same, orange higher. That doesn't tell me too much on its own. I already know that green and purple are both the same in terms of body mass, and orange is higher. I already know that. That's not new information from this. I can see that clutch, purple versus purple, they look about the same. Green versus green looks about the same, and orange versus orange looks about the same. So clutch size uh, doesn't appear to be an important predictor. Compare that to sex, where I've got purple versus purple, female versus male. Male is higher body mass. Green versus green, male is higher body mass, and orange versus orange, male is higher body mass. So the sex of the biological sex of the penguin might be an important predictor. Scroll down a little bit. The plots in this area are quite a bit harder to interpret, but some of them might show some interesting things. For one, if I look at which one of these columns was delta 15? So I got to scroll up to see. So this column is delta 15. Oh, I wanted 13. 13 had this weird pattern. So let's look at delta 13. I can clearly see these 3 stripes that I saw over here. these two plots are showing essentially the same thing. They're just giving me another way to look at comparison of the data just for delta 13. And those spikes don't appear to be explained by anything. There's something interesting happening with delta 13. I'm not sure what it is. Something also with delta 15 happens. Oh, that's still 13, never mind. With delta 15, we don't see those sorts of stripes in any of the plots that show me anything about delta 15. So going into modeling, delta 15 is going to be easier to work with. Delta 13 has something else underlying it that I don't think has an explanation in this data, unless you can come up with something on your own. I'm not sure what that might be. These plots here don't tell me too much. One thing is this is clutch size, so so this one is sex, that's clutch, that's island. These two are island. So this is clutch, and if no, there's almost no data. Stop drawing so many circles. For no, there's almost no data. Yes, there's a lot more data. So again, clutch size is not going to be a useful thing to include. And we see the same pattern we've got purple on all of the islands, but orange only on one island and green only on one island. And then this one is just species, and it's telling us we've mostly got purple, some green, and a moderate amount of orange. Things like what's sex and species was an interesting one. How do we get sex and species? So sex and species should be here. Oh yeah, so right. It doesn't look, sorry, I should have been pointing at this one when I was talking about mostly purple, a few green, middle amount of orange. Looking at this plot here as a whole, we don't really see a difference in the height of the purple bars. We can look over at the x-axis. We have 20 and 20 on the y-axis. I said x before. 20 and 20 on the y-axis, meaning they have the same height axis, and it really looks like orange has the same height, green has the same height, purple has the same height. So for each species, we do seem to have 50% male, 50% female, depending on maybe some like small variations in that, but otherwise not too much of a difference. Clutch, again, if I look at the clutch column for species, we have really low data, but we also, yeah, I'm going to stop talking about clutch. That's not overly important. I'm going to scroll up a little bit and look at delta 15's box plots just to see what's going on with some of these. So delta 15 does seem to be different for different species according to the box plots. I'm not worried about islands. I'm not worried about clutch. And delta 15 maybe is slightly different by sex, but it's really hard to tell from this, and that's something that a model will need to tell us. So I'm going to stop there. There's plenty more to look at in this model, or in this visualization. Coloring by species was extremely important for this. It tells us a lot more about the data. There's a lot of hidden relationships that we didn't see before. Oh, there's one other thing I wanted to mention. So visualizations are important, and it tells us a lot about, by looking at the response, it tells us a lot about what might be in the model. By looking at the association between predictors, we can see where this correlation is coming from and whether or not predictors are correlated. The categorical variables are harder to interpret, but do give us some information about the model. And then from this, we can do further explorations in order to determine what is actually going on between these variables.